Ever wondered how we can study the moon's surface without physically being there? Welcome to the captivating world of lunar exploration, a realm where technology and curiosity unite to unravel the mysteries of our closest celestial neighbor. The moon, with its cratered surface and dusty plains, has been a subject of fascination for centuries. Its exploration is not just about planting flags or leaving footprints, but about understanding the origin and evolution of the lunar landscape. Now, let's introduce a game-changer in this field, the Intuitive Machines IM-1 Nova-C Moonlander. This remarkable piece of technology is set to launch on the 14th of February, and its mission is nothing short of extraordinary. It will carry the stereo cameras for lunar plume surface studies, also known as SCALPSS, a tiny but mighty innovation developed by NASA's Langley Research Center. These cameras will observe the lunar surface and study the impact caused by the lander's engines using an advanced technique called stereophotogrammetry. The valuable data collected will provide insights into the effects of landings on the moon's surface, ensuring the safety and success of future missions. This mission is about to change the way we understand our closest celestial neighbor, the moon. Now, let's dive into the specifics of this remarkable machine, the IM-1 Nova-C Moonlander. This innovative creation is set to launch on the 14th of February, carrying with it the hopes and dreams of the scientific community. But it's not just a passenger vehicle, it's also a mobile lab, equipped with NASA's stereo cameras for lunar plume surface studies, or SCALPSS for short. These cameras will observe and study the effects of the landing on the moon's surface, using a technique known as stereophotogrammetry, helping us understand better how to safely and effectively land on the moon. The IM-1 Nova-C Moonlander is part of NASA's Commercial Lunar Payload Services program, a groundbreaking initiative that has opened up lunar exploration to private entities. This isn't just about getting to the moon, it's about paving the way for a new era of space exploration, where private and public sectors work hand in hand to push the boundaries of what's possible. This lander is not just a machine, it's a pioneer, aiming to become the first private spacecraft to land on the moon. But what makes this mission truly special is what the lander is carrying, the stereo cameras for lunar plume surface studies, or SCALPSS. Now you may be wondering, what exactly is SCALPSS? SCALPSS is a groundbreaking technology developed by NASA's Langley Research Center. It's a system of cameras designed to study the moon's surface in a way that's never been done before. Here's how it works. SCALPSS uses a method called stereophotogrammetry. Think of it as having two eyes that can capture the moon in 3D. When the lander descends onto the lunar surface, its engines kick up a cloud of dust. This dust cloud, or plume, interacts with the lunar surface. And that's where SCALPSS comes in. The cameras capture this interaction in high detail, giving us a unique perspective on how the lunar surface is impacted. But the SCALPSS cameras do more than just observe. The data they collect is vital to our understanding of lunar landings. Scientists and engineers will analyze this data to predict the effects of future landings on the moon's surface. This information will help us to plan safer and more efficient missions to the moon. So, while the SCALPSS cameras may be small, they play a crucial role in lunar exploration. These tiny cameras will provide us with a wealth of knowledge about the moon's surface, helping us to pave the way for future missions. The SCALPSS cameras will provide us with crucial data to ensure the safety of future missions. It's a small camera with a massive impact. So what does all this mean for the future of lunar exploration? Well, the potential implications of this mission are nothing short of revolutionary. The stereo cameras for lunar plume surface studies, or SCALPSS, on board the IM-1 Nova-C Moonlander will provide us with a unique opportunity to study the lunar surface in a way that has never been done before. The data collected by SCALPSS will not only help us understand the effects of landings on the moon's surface, but it could also play a crucial role in designing future moonlanders. This could mean the development of landers that are safer and more efficient, reducing the risk of mission failure and increasing the potential for discovery. Furthermore, the information gathered could significantly influence the planning of future missions. By understanding the impact of landings, we can select optimal landing sites, reducing the potential for damage to the moon's surface and our equipment. This could open up new areas of the moon for exploration and potentially even colonization. This mission is not just about what we can learn from the moon, but also what we can learn about our own abilities in space exploration. It's about pushing the boundaries of what we know and what we can achieve. It's about paving the way for a new era of discovery. The IM-1 Nova-C Moonlander and SCALPSS are just the beginning. There's a whole universe out there waiting to be explored, and with each mission, we're taking one small step closer to understanding it. As we continue to push the boundaries of space exploration, missions like this one pave the way for a new era of discovery.